today is about challenges in deploying operations research projects. But I'm not going to talk about challenges, right? Because I think that we as operations research scientists are here to solve challenges and not to be stuck with them. So I just wanted to rename it to solutions in deploying OR projects. And I or we as my team, and I will just talk about my team in a few minutes, we don't claim to be experts in doing this, but we have found our way to actually put our projects into operations in different parts of our company, which is a very different from the sense that it's a more than 100-year company if you think about Deutsche Post. So we'll just try to share the expertise that we have built. And today I'm presenting here as the lead OR scientist for DHL Analytics Center of Excellence. But most of the work actually belongs to my colleagues, some of them are in the call. I can see as attendees, and some of them are working on other stuff. But even before I start, I have to tell you something. I have a presentation roughly in 3 hours to our group CEO, like Frank Apple, explaining what operations research is and what we are doing with it, right? So I just wrote the slide here, maybe also to get your feedback, but also to show you how we see it, right? How to explain it to a business person. I think this is one of the challenges that we always see. So OR is, and I think there's nothing that you don't know here, but OR is about, of course, giving better solutions, better decisions to problems like lower cost, lower emissions, or getting higher profits. And in most cases, we want to do it faster because we have limited time, limited resources to come up with decisions. These are, if you talk to an OR scientist, a mathematician, these are the two that they will come up with, right? So they will say, okay, OR is about better decisions and faster decisions. And usually if you can do it, a mix of both. But in our case, we have to be applicable. And, this is very different because I have struggled in academia for several years. And this is where actually we are different from industry, that we want to be applicable. We want our solutions to be used by someone and create an impact. Because I will explain a bit of Deutsche Post DHL group in a second, but if you think about our cost base, we spend 20 billion on people and another 20 billion on transportation. And our strategy for 2025 says we want to invest in digitalization and advanced data analytics so we can generate 1.5 billion euros per year by the savings. And if you think about an OR project that, generally you save about 2, 3, 5% compared to baseline. And if you multiply this with these values that you see, only from optimization, you can actually generate so much impact for the 500,000 people working for the group. That's why we take operations research very serious. And whenever we do projects, and you will see that in a second, we always have in mind what is the impact that we can generate for the group, for the environment, and for our people. So was not the regular start, so let me turn back to myself. And we just gave a brief overview. So I'm working in DPDHL group since 2017 October. So in 3 days, it will be a 3-year mark for me. Before DPDHL, I worked for Amazon for a year or so. And before that, I was leading business analytics in Deloitte, Turkey. And also, I worked as a senior OR developer for a software as a service company. I have an industrial engineering degree from Bilkent University in Turkey. So you can see from 2008 to 13, there's not much related to OR. I did a lot of IT. And I think this helped also from a mentality perspective when we are now talking about the projects that we are putting into operations. But I always wanted to be on this side of operations research, and I always had fun doing that. I will briefly give an overview of what the Deutsche Post DHL group is. I don't know how many of the participants are from Germany, so they will know partially, but I think it will be a good reminder, also good information for others. We are two strong companies. Like we are Deutsche Post, the postal operator for Germany, and we are DHL, the logistics company for the world. We are one of we are the biggest mail and parcel provider in Germany, and I think we are one of the biggest in Europe. We are a global e-commerce enabler by our express services and also e-commerce services. We are, number one in express delivery. We are leader in forwarding. We do everything around logistics, right? From parcel mail, from the most basic, and I don't want to call it basic, to more advanced or warehousing and complete management of transportation. So as an OR scientist, actually, we are in a place that many challenges are there for us to solve, and we are trying to pick the ones that are having the biggest impact. As the group, we have 5 different brands or 5 different sub companies, which is Post and Parcel Germany is the biggest from I think revenue perspective. Then we have Express, which is international shipments, usually time definite shipments. So if you want to send something from here to Turkey next day, then you would probably use Express or one of our competitors, of course. Global forwarding is and freight is for bigger items, for usually pallet-sized shipments, that is traveling internationally or also overseas. Supply chain is our 3PL operation, 3PL business, where we do warehousing and transportation management for companies so that they can focus on their commerce or their business. And e-commerce, previously being part of Post and Parcel, is our international parcel service, mostly around Europe. And we have another function, which is corporate incubations. Maybe you know about Street Scooter that we own. This is also part of corporate incubations. We, as the Center of Excellence, we are in the corporate center, and that means that we work with all the divisions actually shown on the slide. And I want to just keep it short, but if you think about the size of this organization, we exist in more or less all the countries and territories. So some of them we are not even allowed to call countries. The 220 of them, and we have 550,000 employees, and the group has 60 billion, I think more than 60 billion euros of revenue. And yeah, I think we are delivering crazy number of letters, parcels, air freight, ocean freight, everything around the world. And our center is in Bonn. I'm also in Bonn today, but not yet in the tower. So in an hour or so, I will suit up and then go and present to our group CEO what we do. Great. I just want to talk about how we see data analytics. And in 2014, before I joined, of course, there was a team of 2 people who built this data analytics center of excellence as a central function, just to come up with solutions to business problems. And in 2016, the COE was approved from the board, and from then we really kicked off. And since 2017, end of 2017 and 18, we started doing data lake, and also we started increasing our expertise in operations research. But of course, we still have quite a focus on machine learning forecasting projects, which is I think again at least 50 to 60% of our projects are still on that field. So we are trying to cover everything around data science, and we have a very international team with a lot of different backgrounds. But we are not the only people who are doing data science for Deutsche Post DHL Group. Actually, we have around 120 people, I think, around Bonn only, and probably around 200 to 300 around the world. And even from an operations research perspective, we have a team of 11, I think, currently. And there are several more teams, one in US, and I think a few more people in the departments who are doing operations research on their daily jobs. And yeah, this is also another way of looking at it. So we do a lot of projects in different fields: network design, routing, optimization, staff scheduling, and then we do forecasting, analytics, predictions, anything that you would have, for a normal logistics company. And on top of the projects, we have some standardized solutions, but I don't want to go into detail of them. Of course, I would happily answer any questions if you have around them. So for the presentation today, it's for Frank Apple. I looked at our roadmap. So we asked all of our business units to come up with what they want to do in the next 3 years for their business units as data science projects, right? And this includes machine learning projects, more RPA kind of projects, sometimes some BI kind of projects, and then I started classifying them, and we see for a logistics company, actually, the number of operations research projects might look a little bit low. The share might look a little bit low, but this number has been increasing quite significantly for the last couple of years and couple of months. And actually, we see that some of these projects are really at the core of all the operations of Deutsche Post, DHL. And this is where we want to focus on, just first solving the most core problems, creating solutions to our last mile, for example. We'll talk about them in a few minutes, but I want to come back to what I've shown and what I was shown today to Frank Apple. What we have seen in the last 3 years is when you want to do operations research in a business environment, of course you have to be better than your baseline, and of course you have to be fast enough to solve the actual business problem. But the real thing that ticks, that makes your project from a research project to a real industrial application, is being applicable. And there is no single solution to being applicable, right? So we had different projects doing different stuff, and they all found their own way to be applicable. I think the mindset that we tried to bring was that we will never be perfect. We will never be perfect. So we have to live with it, and we have to find ways to overcome this. I will talk about the 3 routing projects today, and for 2 of them I will go a little bit deeper, and for the third one I'm unfortunately unable to go deep, but I will try to explain what we do. And I hope you will like it, and I hope you will find it inspiring for deploying OR projects, how you can tackle some of the problems that you can see. So the first one is Optimierung, so for the German name. So it's a sequence optimization for mail people. And the second one is Raptor, our transportation optimization for pickup and delivery for freight shipments, so pallet-sized shipments, usually L2L business, that's dedicated to some of our customers. And the third one that I will slightly discuss about is Zoro. I won't say the German name, I can't do that, but it's courier-oriented routing optimization. This is our last mile solution for parcel Germany. So let's start with Raptor. By the way, if you noticed, and yeah, actually now we don't have it, but we used to call Zoro the T-Rex. So we had 2 dinosaurs and we had Go, and somehow it really stick with the people. So this might be a good, nice first hint that if you have a project that you believe will add some value to your business, find a catchy name, because it really sticks with people. Tobias Meyer, our CEO for Deutsche Post and German parcel business, actually uses it a lot in even public announcements. So please make sure your project always has a catchy name. But of course, this is just part of the joke. So Raptor is for routing, pickup, and delivery, where the shipments are actually bigger, right? So you have 3 to 4 shipments in a single vehicle, and the vehicles are not ours. So we are just the intermediate broker between companies. So this is specialized tool for one of our businesses. So we have a special network for an automotive company, like and we are trying to optimize their pickup and deliveries from their suppliers. We have different DHL customers actually who can use Raptor, but now we are just focusing on this first customer. And you can use this tool for operational planning or even to strategic planning if you are, because our business is a lot with RFQs, so requests for proposals or requests for quotes. And if you know how low can you go with your costs, then you can be more competitor in your pricing. And for many things, we have different user interfaces around the group, right? So many different businesses use different customizations of the same tool. So we said we would design Raptor as a single web service that serves these different interfaces from a single source. But we said, okay, some of the customers have other needs, like dangerous goods, for example, or maybe if you don't want your shipments to go outside of European Union, so you have to not route from the shortest this path, but from a different path. So we said, okay, Raptor is a set of algorithms, and there are some base methods that we solve our problems, but each customer can also have their own customization. So then you can only then you can be very close to the business that you are solving. Only then you will be getting acceptance from the people. So in this case with this automotive company, we usually do 1,000-ish shipments from suppliers to plants, and then we take back the empty goods to packaging of the materials. And there's a high variation in order size and weights and the shapes, right? And we can do it in three ways. We can either do a mid run and send it directly to plant, or send it to a cross stock. Then it would be merged with other shipments and then consolidated and sent to the plant. Or we can say we don't want to do this because it's so expensive. So we have a freight terminal there whose job is to do L2L business, but not only for this company. Then we say, okay, we want to just sell it out. So you have to find a balance when you create a transport. Does it go to cross-dock or does it go to directly to plant? Or do I say I don't want to do this? And the constraints are quite crazy. Like you have very standard constraints like driving working times, time windows, you have loading capacities in weight and volumes. The planners want to have robust schedules, so if there are some problems in the road, you have to be able to make sure that you can actually get them. And you have to have last in first out because truck is a physical object, right? So you can't really just go from in between shipments to pick up the first shipment. And you can only stack a few of the items, and depending on the constraint, like depending on the item, sometimes you can only put one of the item, or you can stack three of them. So this is very interesting because this came up so late in our project. So we made a POC and we said, okay, we can save X million for this company. It sounds quite good. And we started doing, sending out routes. And eventually it turned out that the planners knew what the shapes of the items were, and they knew how stackable they are. And they would say, okay, this is not possible. And we said, okay, you can do volume. The weight is okay. Why can't we do that? And then they said, yeah, but the shape. And then you see all these constraints that looked very normal, let's say driving time or time windows are very standard in most of vehicle routing projects, that when you go closer to the business, actually you see other stuff that you normally don't see in the literature. So you have to find out ways to do that. And I just brought a one page on how we are doing this Raptor planning. But what we do is actually creating the tools, trying to do a construction heuristic, and then we do large neighborhood search for several iterations and return the best solution. So it is not rocket science, or from one perspective, it's not rocket science. From the other one, when you think of how you need to incorporate all the constraints that the dispatchers have, you have to be very adaptive to the changes. And how we did that was, I actually say this very proudly. from the initial meeting for the project, it took us only 3 months to go to the operations, go to the dispatchers, and start giving them through. So we made a very loose, very bad integration. It was running on the desktop with, where we struggled to install Python, but we were able to get the daily shipment data on an Excel, and we would create schedules, and the dispatchers would start checking them, confirming some of the truths, and giving us feedback. And our people, our team, would take this feedback, do changes. It can be a new feature, it can be a new constraint, it can be even a new shared Excel file that they can put information that can overload the daily shipment data that they know, but somehow it's not reflected in the data. And it took us another 6 months to do this loop to make sure we get 100% acceptance. I think this was the key to success here, that we tried to be as soon as possible on the field with the real people, the real end users of this project. And this allowed us to make sure Raptor is now in operation, I think for the last since the beginning of 2020, but we had the COVID break in between, so this plant was closed as for the other automotive companies. But for the last couple of months, we also see and we track the impact it's generating, and this impact is significant money for this business, significant savings for this business. So as a summary, one of the learnings was to be in the production as soon as possible, find your way to go and integrate into operations as soon as possible, and have a very close feedback loop that would enable you to be, adapt to business specific constraints and uncover them, because people, and especially if you're working with, operational level people won't tell you from the beginning. They don't know what optimization will end up like, right? So you have to show them the results as soon as possible and be ready to be challenged for it. And of course, now on top of the cost savings, our planners actually have more time, because planning 1,000 shipments actually took them hours to do, and now with Raptor it's taking minutes. That they just quickly look into the results and then they dispatch it, and now they have more time to find cheaper transportation, which brings another savings to our business. So this is it for Raptor. Looking forward to hear actually questions from your side on Raptor, and I will talk about Gangfolge Optimierung or Gang sequence optimization for Postman. Just to give you an information, especially if you are not from Germany, maybe you don't know, we have to, as Deutsche Post, we have to deliver 6 days a week to every household if there is a letter the next day. So whenever you send something, if it's not a Saturday, it will be delivered the next day. And we can't design our networks to say, hey, I don't want to do this area today because it's so costly. If there is a letter, you have to go there and you have to be there. So what we do is we divide Germany into managerial areas, Niederlassungen, and each of them are divided into different delivery bases. And then every delivery base is divided into districts. So every district is served by a postman or a woman. And these people are either driving a car or riding a bike or walking. Just to give you the size, we have 85,000 people working in post delivery as postman or postwoman, and 55,000 of them are driving. So they're doing the urban regions, and the rest is either riding a bike or walking. So this is a very big problem if you think about, and this is I think most of our cost base in postal delivery, like this 85,000 people that you have that has to work every day. And this is how it looks like. This is a single delivery depot, and the geometric shapes that you see are actually the delivery districts that you have. Now, one thing that you have to know, to make sure a postman is efficient, he or she always has the same route to walk. So It's called a sequence or Gangfolge in German, and it's the same for every day for now. So sometimes Mondays are a little bit different because we have less volume, but you can't just have a sequence that's half baked because the letters actually are sorted in this sequence. So the sequence that he walks is actually followed. He or she has the letters in his hand, and they are sorted in the same order. So you can't just change them, or you can't just not be vague about it. You have to be very clear. And when you want to change a Gangfolge, this is what it looked like. So this is the list of one person walking every day, and this is how they used to make changes, right? So they would, there would be a person eventually putting this into a system, and then say, okay, this is the new Gangfolge. This goes to the machine for sorting, and then it will be implemented. So it sounds like a TSP, right? So you have X hundred stops that you want to stop. It sounds like a TSP, but the reality is not like that, because first you have to understand the roads, how they look like. And for this, we used OpenStreetMap to create a post map actually that consists of the nodes and edges with attributes that we need, right? Can we drive in the street? Can we ride a bike in the street? Can we zigzag on the street? Can we do a U-turn? And we allowed our planners to be able to change these ones. This allowed us to create a very detailed network. So we took the OpenStreetMap and we created a detailed network of which roads can be walked, which roads can be driven, where can we do a zigzag? Maybe you can see it here. Everything, all the options that you can have. And we separated car lanes, the left and the right, and we separated pavements, and we separated house connections. And it still sounds like a big TSP, but this is not the case in reality, right? What people do, especially if they're driving or riding, they stop somewhere, they take a bunch of letters, they make a loop, and then they turn back to their vehicle and go to the next loop. So each time you serve 4, 3, 5 houses, and then go back to your vehicle and then look again. So they always change the means of transportation. So the first thing that we did to solve this was just to understand, given a sequence, what are the loops that they are doing, right? So just to take it out of the sequence from what we see, once you can evaluate this, so once you know when he stops, when he drives, and when he walks, only then you can understand what are the underlying constraints, underlying parameters, and then you can start looking for an optimization that does the sequencing based on the loops that the person wants to do. And this is how we do it, is that we try not to create a solution from scratch, because usually they don't want to have this, but we do local search techniques. So we search what we, if we can, take parts of the sequence and put it somewhere else, can we just do it better? This is how we approach this problem. And we took a very manual process actually into a digital format. And I will show you how it looks like at the end. But we had a lot of also unexpected issues, right? One of the things that we learned is especially when postmen are driving, they want to park on the left-hand side, because then it's easier to leave the car on the left and then deliver there and turn back to the car from the left, so they don't have to go around the car to pick up parcels or letters. Sometimes we have seen, just because of the data was not good, we have seen oversized loops, or we have seen that the map data was not good. What we did was in enabling the planners who would actually know the district quite well, the districts, actually the whole districts in the delivery depot, and we allowed them to make changes. So we didn't say, here's the optimization, you can serve your district 3% in 3% less time, but we just let them take a base and then do the changes they want to do, because they know better, and believe me, they know much better than we can ever know. So this was the only way that you could make sure this project would go live. And it is now how it looks like today. So on the top, you see a lot of buttons that would help the planner to optimize or evaluate the current route. But the rest of the buttons are for adding roads, deleting roads, changing the attributes of the roads, all the things that you might want to do with your either sequence or underlying map data. So learnings from here, this is how it looks like actually. Now the paper is represented like this, and more or less they can do the same changes that they do. But to make sure Go would go live, and it's currently, I think, deployed to all delivery bases, and we have seen millions of data points being changed on our maps. We made it possible to make changes, making data manipulation at the smallest level, right? So you could move a house, you could change where it's connected. Everything was available for changing. So this is how we got the approval of the planners that they really wanted to use that, and a user-friendly tool which made our, when we do optimization, we want people to use it because it's, we know it's 2% or X% better. But we said, okay, we know that we can't have the whole reality. So we just gave our decision as the base, and people don't even have to optimize. But we say, here's a good decision. We think it's a good decision. If you want, take it. You can run a scenario. You can make different versions of it. You can talk to your postman and come up with the best sequence for the company. And I think this was a learning that we had even from the 6 months building the team, that most of the routing problems in real life are not pure traveling salesman people. So this was another learning. Yes, looking at the time, I think I'm going well. And I will just talk about Zora a little bit less detailed than the others, because it's one of the reasons is new, and the second one is we're still looking into patenting parts of it. So it's Courier Zustellerorientiert Routine Optimierung. My German is very bad, but it's courier-oriented parcel, courier-oriented routing optimization, or we used to call it true routing with experience. And this is about parcel Germany. So we deliver, I think, 2 billion parcels per year, and half of them are delivered by Postman, half of them are delivered by special delivery vans, which is around 10,000 to 20,000 per day around Germany. What Post and Parcel wanted to do is to send shipment notification to our customers, so that they know when their parcel is coming. Just from the beginning of the day, if we can tell them your parcel comes between 1 and 2:30, then either they can say, please don't bring it, which reduces cost for us, or they can say, yeah, maybe I should just postpone my meeting with my friend half an hour so that I can get my parcel, so I don't have to wait another day, or I don't want to have to drive to a pack station. And to do this, you need to know how the courier will arrive, right? So this is one region from our parcel delivery, and in a normal day, it's very dense. Like on average, our shipments are around 80 meters apart. So our delivery regions are super dense. And you want to find the best route here, but the only thing is you don't have all the data, right? On the map, maybe here there's a school that you may want to avoid at the beginning of the day, because there are kids there. You don't want to risk anyone's safety, and it's super crowded with parents and cars, right? Or here maybe there's a shopping mall that opens at 10 a.m. so you don't want to go there before. But if you think about the whole Germany, this is immense amount of data that you can't really collect, or even if you can collect half of it, you can't maintain that data, right? And our couriers actually know these regions quite well. Some of our couriers have been working on the same districts for 20 years. So we said, we can learn from past. So we can understand the routines that the couriers has been doing for some time. And then we give them the most favorable tour. Because without knowing the tour, you can't estimate when you will be there. So if you give them something and they do something else, then your predictions will be completely wrong. And we are in Germany, so we can't force anyone to follow our routes. And of course, it's also not efficient because they know this stuff that we don't know. So driving time is more or less 10% to 20% of parcel delivery. The rest is delivery time. So you can't just say, I reduced the driving time by 5%, doesn't mean anything within an 8-hour working day. So we wanted to focus on tour loyalty. And it's very funny from an OR perspective because this is a KPI that you can't measure while optimizing. So this is an objective function that we are blind. We give out a route, and then the next day we get how the courier drove it, and then we can compare and say, okay, the tour was good, or we say, oh, we picked the wrong historical routine, right? But just this idea of learning from the past actually significantly increased our tour loyalties in test regions. So very good that Deutsche Post or DHL wants to scale this up now for the peak season for quite a lot of districts in Germany to just have more and more accurate time window predictions. And I always, we always say this predictive analytics and prescriptive analytics, right? One following other. In this case, we have the other way around. We have predictive analytics that says, here's the routine, and we have optimization that puts it into a route. And then we have another prediction model that says, if this is your route, this is the times that you will be there. And I think that from this perspective, this is a very good example how you can utilize machine learning and operations research together. I will just give an example, and I'm still looking at my time. Just wanted to show you how it works. So this is a district that has no history. So the courier was driving it for the first time. And the first day we have, on the maps, the lighter the green is, it's earlier in the tour, and the darker the red is, it's later in the tour. So the first day, and this actually happened. These maps are real. On the first day, we have no history. We said, okay, this is the shortest tour. This is the best we can do. And the courier drove completely the other way around, right? So we had 1% loyalty. So 1% of the stops were more or less within the range of what we predicted them to be. And on the second day, we said, okay, yeah, today's shipments are similar to yesterday's. Then probably you will follow yesterday's routine. And he didn't. And we had very low loyalty again, because probably he thought, yeah, it didn't work in the first day. He tried something else. But we said, okay, we couldn't learn it from these days. So on the third day, we switched back to the other one. And then on that day, he was actually building some of his routines. So we were, for a little bit more than half of the shipments, we were able to know the right sequence. But from the fourth day, he started sticking to his routine, and we were able to get 90% loyalty. So this is our quality measure. More than 90% we have to be. And since this day, every day that he sticks to his routine, we are able to predict and optimize for his routine from the beginning of the day with more than 90% loyalty. Great. So I said I won't talk about challenges. I will talk more about solutions. I hope I was able to give you some insights. I wanted to bring this in. I'm ex-Deloitte consultant, and one of the things I really liked there, how Deloitte looks at making an analytics transformation, which they call an insight-driven organization. They always say something, right? Most of the companies that look into, for example, a data analytics projects, and I don't now talk about only OR, but also data science. They start with the technology. They go to a vendor and they buy a technology. But analytics is more than that. You have to have a strategy and vision. And I can talk about what ours was at the beginning, so 4 hours. But you have to have a strategy. You have to know what you want to achieve with analytics. You have to build up the people And you have to have processes that enables you to put these solutions into real life. In this case, for example, the presentation that I will do to our group CEO is one of the things that we did in DPDHL, building an analytics steering board that is driven by our group CEO so that everyone can discuss their analytics topics, what they want to do, what are the roadblocks that they see, what are the good things that they have done in a very high level executive level environment. And then you had to have data. With OR, it's a little bit easier. I think the machine learning people are suffering more from that because in OR, you either have it good or not, right? And then comes technology, right? Like all of the solutions that you have seen here are based on open source tech, more or less. We also used, OR solvers for some network design projects, for different other projects that I haven't shown you. But the main thing is looking at it holistically. I think this is very important. If we focus on OR, I would just say three things, right? And I was a software developer for a company that does optimization for others, and I would sometimes say, what kind of a silly constraint this is? Who needs that? It reduces your objective. It's not good, right? But that doesn't exist in real life. So you have to be close to operations, and you can't ignore any constraints. You can't ever say a constraint is silly. One of the things that I tried to do within our team from day one was trying to focus on the value we generate, right? Not the complexity of your algorithm, not what methods you do. If you always have, what is the value I'm generating? Am I saving time? Am I saving emissions? Am I saving costs? Or am I just making someone's life easier? That helps you focus on the right things. And right things are not always the fanciest algorithms. Right things are sometimes super simple, and you have to be brave enough to tell a business person saying, you don't need optimization for this. You just need a simple Excel file. And if it's that, you have to make sure that you generate this value with what you have the expertise with, not do what you have the expertise on to do something. And the last one is, I think this I learned from the startup world, that you have to love the problem, not your solution. You always have to be open to making changes in your approach and your data and everything, just to help generate the value that you promised to generate. I hope you liked the presentation. Thank you for listening. Happy to answer any of your questions, and I will just stop sharing my screen.